Sometimes when an integral is really difficult, you can bring on a clever substitution to help you to solve the integral. So in this case, the substitution that I'm going to make is u is equal to 1 plus x. Now I need to make this substitution right across the integral. So let's start that with the limits. Okay, so limits are a good place to start so you don't forget to do it. So if x is 1, what would u be? And if x is 3, what would u be? That's not too difficult, is it? 2 and 4. Now let's look at this dx. We've seen in the chain rule that dx is equal to dx by du. And so what we can do is differentiate our substitution. Du by dx equals 1. Use the fact that dx by du is 1 over du by dx, in which case it's still 1, and then we can substitute that in here. That's going to be equal to 1. And then last but not least, we're going to have a look at the inside of the integral itself. Well, here we've obviously got u to the half, and then here we've got x, which is u minus 1. So it might look like that was hugely complicated, but let's have a look what the integral looks like overall when we make the full substitution. So we've got the integral now going from 2 to 4, u is 2 to u is 4, of u minus 1 multiplied by u to the half du. Well, I can expand that out. That's 2 to 4, u to the 3 over 2 minus u to the half du. And then I can integrate just using what you learned in C1. 5 over 2 minus 3 over 2, 3 over 2 going from 2 to 4, blah blah blah, answer. Let's try this one. We'll start with our limits. So when x is 0, u is going to be 3, and when x is 2, u is going to be 4, 5, 6, 7. Okay, that's a good start. Now let's move over to the dx. And we know that dx is equivalent to dx by du, so we need to know what dx is equal to. Well, dx by du rather. Du by dx is equal to 2, so dx by du is equal to a half. So this is a half. Okay, now let's have a look at that inside bit, see what we can do. Well, this is obviously u to the 5 here. And then here we've got an x, which is equal to u minus 3 halved. So let's put that all together and see if it's easier to integrate. We've got an integral going from 3 to 7. We've got a half, which I can pull out the front of the integral sign. U minus 3 times another half. That's the half coming from the dx by du. So that makes this out here a 4. Half times a half is a quarter. Du. Well, that's pretty easy to integrate, isn't it? Half u squared minus 3u from 3 to 7, blah, blah, blah. You can do that now. Excellent. Okay, let's try this one. We start with our limits. Ooh, no limits. Woohoo! Less jobs. We don't have to bother with this job of changing the limits. But bear in mind, if you're not going to do that job, if you're getting out of that job, then you are going to have an extra job at the end. So there's one job or the other. So you're going to have an extra job right down when you finished. So don't forget that. If there's no limits, then there's no job at the beginning, hooray, but there is a job at the end, which we mustn't forget. Okay, next job, let's look at the dx. We know that dx is equivalent to dx by du. We differentiate our substitution. Du by dx equals minus sine x. So dx by du equals minus 1 over sine x, which I'll just leave like that for now, but I could equally write as minus cosec x. Either of those is fine. Okay, so now I know what goes in here. Let's look at this other middle bit inside here. Sine cubed, that's easy. Oh no, it's not. U is cos x. I thought u was sine x, but it isn't. Okay, that's not obvious, but I'll come back to it in a minute. Let's have a look at where we've got up to so far. Sometimes if you do that, then things start to get a little bit more obvious what you can do next. So I've got sine cubed x, which I know I don't want any x's. My x is meant to be substituted off. and my u's are coming in. Then I've got dx by du, which is minus 1 over sine x. So far my u's are not doing a very effective job of being substituted in. But look what can happen now. This sine x cancels with one of these, which leaves me with the integral of minus, which I can pull out, sine squared x du. Now I haven't managed to bring my u in yet, but I can see what I can do now, because sine squared u is sine squared x is 1 minus cos squared x, and 1 minus cos squared x is 1 minus u squared. So what I've got here is minus the integral of 1 minus u squared du, and there I've managed to make my substitution. In fact, I'll put that minus sign inside and make it u squared minus 1, I think. And then I can go ahead and integrate. A third u cubed minus u plus c, because there's no limits. Now here's our extra job that I mentioned earlier. The extra job is to unsubstitute, to substitute them back again to how it was originally. So u's going to come back off the playing field, and cos x is going to go back on. Maybe he just had a small leg injury. He's had some physio now, he can go back on and play. Are they allowed to do that in football? Swap them on and off? I don't know. But that's what's allowed in maths, it's fine. So we've got a third cos cubed x minus cos x plus c, and that's our final answer. Okay, last example. Again, no limits on this one, but that means I need to remember to my limits at my re-substitution back at the other end. So let's start substituting. We go to our dx, change it to du by du, differentiate our substitution. Du by dx is sec squared x, which means that dx by du is 1 over sec squared x, which I could write as cos squared x, but probably won't bother given what's going to happen in a minute. So now looking at the inside of our integral, sec to the 4x, not obvious what that is in terms of u. Our dx by du is going to be 1 over sec squared x, and we can see that we're going to get some cancelling. And that's why the substitutions are so clever, because they simplify everything down. So we've got sec to the 4x, remembering we're trying to get rid of all our x's here, get them off the playing field. No x's allowed. So this sec squared is going to cancel with that sec to the 4, giving us sec squared. So we've got the integral of sec squared x du. We still haven't managed to get it in terms of u yet, but I know the formula. I know all of the formula, and so should you. 1 plus tan squared x equals sec squared x, and therefore this is equal to 1 plus u squared. So actually what I'm looking at here is the integral of 1 plus u squared du, which I can integrate really easily. Don't know why I did that, I'm going to integrate it. So it's the integral of u plus a third u cubed plus c, because there's no limits. And then remembering that because I didn't have that job at the beginning, I've now got the job at the end of substituting them back again and letting x come back on. So all we have to do is replace our u with tan x, and we get tan x plus 1/3 tan cubed x plus c.